Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be studying this lesson about Pythagorean Theorem. This theorem is used to find the length of one side of a right triangle when the two sides are given or known. Pythagorean theorem is only used for right triangles. Okay, so in here, we have this right triangle. And in this right triangle, this is our right angle. In a right triangle, there is what we call the longest side or the hypotenuse of a right triangle. To easily locate or identify the hypotenuse of a right triangle, first identify where is our right angle. Opposite side of that right angle is the hypotenuse of that right triangle. So in here, opposite side is this side. So it means this is our hypotenuse. If we will square this hypotenuse or hypotenuse square, this is equal to the sum of the squares of the other two sides. So other two sides are this side. So hypotenuse squared is equal to the sum of the squares of the other two sides. So it means c squared is equal to a squared plus b squared. And this is our Pythagorean Theorem. Okay, now I will be explaining or I will be proving that this Pythagorean Theorem is really correct. Okay, first, we will be using the concept of similar triangles to prove that Pythagorean Theorem is correct. So in this figure, we have here right triangle ABC. So right triangle ABC. This is our right angle. So it means hypotenuse is this opposite side or this side BC or segment BC. To make it more simple, let's name this hypotenuse or segment BC as A. Okay, this side, we will name this B, and this is C. So in this right triangle, Pythagorean theorem would be a squared, because this is our hypotenuse. So a squared, that would be equal to the sum of the squares of the other two sides. So b squared plus c squared. Okay, now, let's prove that this is correct. Okay, in our episode, in episode 191, okay, we already studied there the right triangle altitude theorem. And I mentioned there that if we are going to draw a straight line from the right angle perpendicular to the hypotenuse of the right triangle, then this point is what we call perpendicular foot. So in here, point D is our perpendicular foot. So when we draw this perpendicular line, we now created this right triangle and this right triangle. So total, we have 3 right triangles. And these 3 right triangles are similar triangles or similar figures. So we have here right triangle ABC. We also have this right triangle ABD. So ABD. And this right triangle ACD. Okay, in this right triangle ABD, let's name this side X. And in this right triangle ACD, to make it more simple, let's name this side Y. Okay, now, focus to this right triangle ABD. In episode 191 about right triangle altitude theorem, okay, this side of this right triangle from this point, square. If we will square this side, it would be equal to this side times this side. So it means this side, we will square this side, it would be c squared is equal to this side. So this is x, okay, times this side, or this is a. So we have x times a. Okay, also, we have this side in this right triangle ACD. So from this point to this right angle, if we will square this side, so we have here b squared, this is equal to the product of this side times this side. So this one is y. So times this side is a. So y times a. So if we are going to add c squared plus b squared, then it would be equal to, since this is common, a is common, so we can just write a, okay, times, we have here x plus y. X plus y is actually a. So it means a times a is not 2a. This is a squared. Okay. A squared is equal to c squared plus b squared. So this is Pythagorean Theorem. That's why here is correct, or Pythagorean Theorem is correct. So we prove that Pythagorean Theorem is really correct, and we use these similar triangles. Okay, moving on. This time, let's prove Pythagorean Theorem using areas. So, as you can see in this figure, we have this right triangle. This is our right angle. If this is the right angle, then it means this is the hypotenuse of this right triangle. So in this right triangle, Pythagorean theorem would be, so a squared is equal to the sum of the squares of the other two sides. So b squared, so a squared is equal to b squared plus c squared. Okay, let's prove that this is correct. Okay, this side of this right triangle is C. So it means this side also. So if you're going to take a look at this square, if this is 1, then this is also 1. So in here, this is C. So it means this is also C, or this side is also C. So the area of this square is C times C, so it means C squared. Okay, what about in this side of this triangle? This side is B. So it means this side is also B. So the area of this square is B times B. So this is B squared. Okay, now what about in this side, or the hypotenuse of this right triangle? If this side is A, then it means this side is also A. And that means the area of this square is A times A, so it would be A squared. Okay, Pythagorean theorem is a squared is equal to b squared plus c squared. So, it means this area is equal to the sum of the areas of these other two sides of this right triangle. So, as you can see, in this square, we have here right triangle. Okay, this is also right triangle, right triangle, right triangle. So we have 1, 2, 3, 4 right triangles, and this is one square. So total 5 squares. One right triangle here is equal or equivalent to 1 square. And to prove that one right triangle is equal to 1 square, okay, take a look at this right triangle. To find the area of a right triangle, it's actually 1/2. Okay, so here is 1/2 times base times height. So base is 1. Height is 2. So 1. 1 times 1 times 1, then that would be equal to 1. So it means one right triangle is equal to 1 square. So this is 1, this is 1, this is 1, this is 1. So 1, 2, 3, 4 plus 1, then this is equal to 5. So a squared here is equal to 5. Okay, what about b squared? So as you can see here, b squared, we have here 1, 2, 3, 4 squares. What about here? We have 1 square. So 4 plus 1, that would be equal to 5. So Pythagorean theorem using areas is correct. So we prove that Pythagorean theorem is correct. Okay, this time we will be answering this concept check question. Okay, according to this, we will find the values of x and y in the following figure. So we can find here two right triangles. This is one right triangle. We also have another right triangle here. So this is x. This is y. Okay, first let's find what would be the length of this side. So what would be this x? And this side is part of this right triangle. So this is our right angle. Opposite side is this side. So it means this is the hypotenuse. So Pythagorean theorem would be, okay, x squared is equal to the sum of the squares of the other two sides. So this is 5 squared plus 12 squared. So we have now x squared. 5 squared is 25. 12 squared is 144. So 25 plus 144, this is now equal to 169. So x squared is equal to 169. Square root of 169 is 13. So it means this side is 13 centimeters. Okay, now what about in this right triangle? We will find the length of this side of this right triangle. Since this is our right angle, so it means hypotenuse or opposite side is this side. So this is our hypotenuse. So Pythagorean theorem would be 15 squared. This is now equal to y squared plus, okay, this side, 12 squared. 15 squared is 225. This is equal to y squared plus 12 squared. This is equal to 144. So 225 minus 144 is y squared. 225 minus 144, this is equal to 81. So square root of 81 is equal to 9. So it means y is equal to 9. So this side is 9 centimeters.